we're getting closer to being able to draw something onto the screen, draw the ship or that kind of thing. If you remember back when we were originally drawing the ship and the boundaries and that sort of thing, we had to create some buffers. Okay, we had the array buffer. We created those buffers using OpenGL commands. Then OpenGL would manage these buffers for us. We would send data down to those buffers, and then OpenGL would draw from those buffers. Ideally, we only send the data down to the buffers once. However, we're doing it multiple times. When we get further into graphics, we'll do a much slicker way. For now, we're creating the array buffer and the element array buffer. The element array buffer is for the individual indices. We need to create these buffers so that we can send the data down to OpenGL. I'm going to do something a little bit hackish. I'm just going to create a buffer that's big enough for a while. And ideally we would have some advanced buffer management where we keep track of how much data we actually needed, create the buffers at the right size, that sort of thing. Where our game's not near as complicated as it will become, and when it becomes more complicated we'll come and revisit the size of our buffers and that sort of thing. For now, I just want to create some buffers and reuse them over and over again. Let's keep it simple. The purpose of this whole refactor is to clean up that MyGL window, this big hodgepodge of all of this code. So let's declare. I noticed actually offline, I can't remember why I took the const off, but it's important to have the const here. I think I was telling you if without the const, then we have to initialize this per instance. But if it's const, if it's const and it's static, it's now a compile time value, and the compiler can use it to initialize the size of these arrays. Let's go down here. We need another constant, static const uint. Little side note, in C#, if you make something const, C# throws the static in there for you, but not in C++. Let's do max buffer size, and we'll start out with a K. Let's just do a K. That's about roughly 1,000 bytes, but a power of 2. We're going to create buffers that are essentially a K large, 1,000 bytes large. The best place to create our buffers is in the initializegl function, which is invoked after Qt gets OpenGL ready to go. So initialize GL, protected function, Control C, go to our CPP file, and textually it's above the paint event. So I'm going to find the paint event. Actually, I think it's probably makes more sense to put it with this other initialization code. So I'll put it right here. Initialize GL renderer colon, and here we need to create our buffers. We need to initialize our buffers, that sort of thing. But before we do that, remember the GL extension Wrangler library or glue, which has to be the first thing that is included before anything else. And then this one's going to get a little tricky because we can only call glue init in the initializegl function after Qt has set up the context for OpenGL. You probably don't understand what that means, but just roll with it for now. GL enum glue init. Let's do status gets glue init, and then I want to assert status is equal to 0, meaning everything is fine. If everything's not fine, then assert will crash, and again we'll come back and make our own assert, which will do some logging and that sort of thing later. GLGen buffers. I want one buffer, and actually we're going to need two buffers, one for the vertex array and one for the index array. So I'm actually going to put those right here. GLU int vertex buffer ID. GLU int index buffer ID. And I could technically, this is just something I want to point out, but I'm not going to rely on it. I can say, hey GL, generate for me two buffers at the address of the vertex buffer ID. Let me do a new vertical tab group here. I can say the address of the vertex buffer ID, which would be safe because right after the vertex buffer ID in RAM, with the layout of the renderer class, the index buffer ID will be right after the vertex buffer ID. So GL can safely write out 2 new vertex buffer IDs to that location in RAM, but that also hurts the maintainability of this class. Say sometime later I felt like I wanted to insert another ID in here or do something different, and so just for the sake of maintainability, I'm going to say give me 1 vertex buffer ID, GL gen buffers. Give me another with index buffer ID. And now I know I can move these around. I don't need to worry about getting bits later by trying to make some changes here. Another option would be to just say buffer IDs and start out with 2 of them or something like that. But I think for the sake of simplicity, we'll have a vertex buffer ID and an index buffer ID. Generate those buffers. We need to create some memory for those buffers. Do you remember how to do that? GL bind buffer. GL array buffer. I want to bind the vertex buffer ID to the GL array buffer binding point. Hopefully you remember what that means and what that does. If not, go back to where I explain buffer objects and the binding points and that sort of thing. And GL bind buffer, GL element array, boy, all those options, array buffer, and I want that to be the index buffer ID. So I now have these 2 buffers bound to these binding points, and now I need to tell OpenGL, hey, create some RAM for those buffers, allocate some memory. So GL, actually we'll do this with a line in between, GL buffer data. The buffer that's bound at the GL array buffer binding point, which happens to be the vertex buffer ID. Create max buffer size amount of RAM, but don't pass any data to it quite yet. And we're going to be updating this buffer every single frame. So GL dynamic draw. And remember, this is dynamic draw. This is simply, this last argument is simply a hint to OpenGL to tell it how we're going to use the buffer. GL element array. I don't even know why sometimes I use IntelliSense, because it gets kind of crazy like this. Element array buffer. Max buffer size. Again, just kind of a hard-coded constant for now. We'll get back to doing something cool there. Don't pass any data down. I think I'll get rid of that for now. And we'll also update this every single frame as well. So there we go. Let's just review. Generate the buffers. Bind those buffers to the respective binding points. And then now take the buffers that are bound to these respective binding points and allocate some room for them. Okay, there's a difference between the actual buffer objects and the room, and I talked about that in those previous videos. So there we go. Initialize GL. We've created these buffers. Now to be clean, in the shutdown function, I'm going to say GL delete. Is it delete buffers? Delete buffers. 1 buffer, the vertex buffer ID. Delete that one, and then GL delete buffer region. No, buffers 1. Does it want a pointer here? I think it does want a pointer here. Yep. So I have to take the address of that integer. Index buffer ID. So hopefully you're seeing, yes, cleanly. Let's create those. Let's, whoops. Let's delete them. But we need to be a little intelligent here. What's the red squiggly about? Oh, I got an uppercase S. Uppercase S. Lowercase s. If I tell GL to delete a buffer, say for some reason this doesn't execute, and then we call shutdown and we tell OpenGL, hey, delete a buffer that we never really got around to asking you to create. OpenGL will just kind of ignore it and go into an error state and that sort of thing. And we can get that error by calling GL get error, but I want to be a little more intelligent than that. So actually in the initialize function, I'm going to say vertex buffer ID gets -1. And the index buffer ID gets -1. And then we'll check here. I'll say if vertex buffer ID is not -1, then that means we probably initialized it to something. So go ahead and delete that buffer. And same thing here. If the index buffer ID is not -1, then go ahead and fry that as well. Chances are, if this is not -1, this will also not be -1, but we'll do the checks separately. And I also want to point out, if I hover over this, you see that vertex buffer ID's type is GLUint. Alright, so I'm actually using a dirty little trick here between signed and unsigned values. When I compare it to -1, I'm actually comparing it to the max value of a GLUint. If you go look at my binary videos, my binary arithmetic, binary numbers videos, you'll learn that to have a -1 with the 2's complement notation, it's basically turning on all the bits, or the equivalent of the max value of a unsigned type. So I'm just kind of reserving this max value. When I say -1 here, that's max value. People probably frown upon that technique, but hey, this is my playlist and I'm going to use that. So there we go. Initialize GL, generate those buffers, clean those buffers out. In the next video, we're actually going to use those videos and see if we, or not those videos, those buffers, and see if we can get drawing